Bandwidth for First Updates Now is supported by the Blue Alliance. Keep up to date on all live and archived FIRST Robotics events and team stats at thebluealliance.com. First Updates Now is brought to you by Twitch. Fun is now a Twitch partner and offering some awesome subscriber-only benefits. Subscribe today or get a free subscription each month when you have Amazon Prime by linking your account and clicking subscribe. Good evening, and coming up on First Updates Now, a special presentation we have here today. It's time to get down and dirty with LabVIEW, and we're going to get the inside scoop and expertise on how LabVIEW can help your FRC team. We have some awesome prizes for those watching today, including a Robo Rio, courtesy of National Instruments. I'm Tyler Olds, and well, to start off, guys, I am not the person you want talking about anything close to programming, but we do have a fantastic expert here today. So please welcome longtime firster and the guru of LabVIEW from National Instruments, April Riddett. April, welcome to the show.
Hi guys, my name's April. Like Tyler said, I've been involved with FIRST for about 2 years now. I work here at National Instruments, and I'm really excited to get started with LabVIEW for FRC tonight.
Yeah, it's going to be a great time, and as we mentioned, great prizes. We'll talk about that in just a little bit. April, tonight is the first of a four-part series we're going to be doing with LabVIEW, which is a great option to utilize to program your robot, really no matter what level FRC team you are, or no matter what resources you have for your team. Could you give us a brief on what we can expect to know about LabVIEW tonight? What are we actually going through?
Yeah, so the goal of tonight is to get you guys familiar with starting from scratch with LabVIEW. So we're going to go over how do I install the update suite, how do I go through the driver station, and then what does the typical robot project look like? So by the end of tonight's show, you should be able to use LabVIEW to drive your robot.
So, as mentioned, it's a four-part series. We'll talk about what's coming up later for that, but we're excited to dive right in. So a couple of things we want to talk about before we get into that is first, we know many of you here because you're excited about the Robo Rio giveaway. We'll talk about that in just a second. So first off, we do have some trivia questions that are coming up too as well. So for that, both things, guys, if you're interested in being part of the giveaways for that, make sure you click that follow or subscribe button for just a few bucks a month for the subscription, or for free through Twitch Prime if you're interested as well. We appreciate your support. So what's going to happen is for the trivia questions, those are brought to you by Andy Mark. We're going to be showing those up on the screen. You'll have a couple minutes to answer. We'll randomly pick a winner for that, and then at the later on in the show, we'll be doing the Robo Rio giveaway. For that, you'll just have to type in the keyword that's up on the screen, or that we tell you to do. So all you got to do is type in the keyword. If you're watching with the team right now, I'm going to tell you straight up, get in chat right now. You can have one stream up, that's okay, but get in chat and get ready to type those keywords, because the more entries and the more people on your team that type it in, the better chance you have to win that Robo Rio. By the way, if you do have any questions about the presentation or anything for April or anything LabVIEW related, go ahead and put at First Updates Now in chat. Post your question and we'll get April right on that for you. So April, you ready to jump into the fundamentals of LabVIEW?
Sure, let's go.
Yeah, let's hop right in. We got a slide presentation here. We got some live demos we're going to be doing too today, right, April?
Mm-hmm. Yeah, we have a live demo coming up about halfway through the presentation. At that point, if you want to open up LabVIEW, follow along, that'd be awesome too.
All right, let's hop into it.
All right, so like I said, I work at National Instruments, and we're going to be going over sort of an introduction to LabVIEW for FRC today. My name's April, and I'm an applications engineer here at NI. Why does LabVIEW matter? LabVIEW is used really extensively in universities, and that's kind of why we're involved with FIRST at the high school level. We're used in 110 different countries in over 7,000 universities. You'll see some big names down there, but it's really, really useful for test and measurement automation. Looking at kind of what we call the LabVIEW Continuum, the idea here is that you can be involved with LabVIEW from kindergarten all the way into your actual career. So starting with WeDo, moving into NXG for FLL, and then obviously Robo Rio and LabVIEW for FRC, and then again that university and career usage. It's a very, very flexible programming language, and it maintains its usefulness sort of throughout your life. Looking at some companies that use LabVIEW, you'll recognize some big names up there. It's just really a lot more widespread than everyone gives it credit for. This here is a great example. This is a really early version of SpaceX's mission control room. Actually, almost every single screen in this picture features LabVIEW, including, you can see the abort button in the top left-hand corner.
So April, what other companies are using LabVIEW in industry currently right now?
So most of the major space companies, so SpaceX, NASA uses us to do all of our testing, along with a lot of companies that are working on developing autonomous driving use LabVIEW extensively to do their testing as well.
Very cool.
So getting into what we're actually looking at today, this is intended to be kind of a quick start guide to LabVIEW. So we're first going to look at setup. How do we set up the software, go over a brief software orientation, look at setting up the Robo Rio, and then dive into the basics of a robot project, as well as getting to driving your robot. So looking at the FRC Software Overview, LabVIEW for FRC comes in two packages. The NI Software for FRC bundle, which includes your LabVIEW installation, real-time, vision development, all those fun, bigger installers. And then what everyone should be familiar with is the FRC Update Suite that every single team has to install, because this gives you your driver station, your Robo Rio utilities, along with the WPI libraries and all of our FRC-specific examples. And those can both be found at ni.com/FRC to download on kickoff for the 2018 season. We'll be looking at 2017 code tonight because 2018 code comes out at kickoff, so we can't show that yet.
Are you sure? I mean, we could leak it. Nobody will know.
I wish. But I think they would find out. So looking at how do we activate our LabVIEW code, this is a question we get a lot. When you get your kit of parts, you'll have a nice big paper envelope in it that has your LabVIEW serial number on the back. And this is what you use to get access to all of the cool features LabVIEW has. So when you install it, it'll prompt you for that serial number. Get it off the back of your envelope. Looking at installing the FRC Update Suite, like I said, every team has to go through and install this, and this contains any major LabVIEW for FRC updates, along with the updated driver station and the updated image each year. And that's really what matters, is getting that new image on your Robo Rio. And then sort of moving on, like I said, every team has to install this, and that's where that LabVIEW activation number or activation code comes in again, and that serial number with the back of that DVD envelope. So let's kind of take a quick look at the software orientation of the Getting Started window for LabVIEW. This is the window that opens after you've successfully installed the FRC Update Suite. If you go to open up LabVIEW and it looks not like this, it doesn't say LabVIEW for FRC, it's not this fun yellow color, you haven't installed the Update Suite. So go install that and then try to open it again. But this presents all of our FRC specific content in a really easy to find way. We have the very important FRC Robo Rio Project, which is what makes you a new robot project, along with the built-in training, the tools, including the imaging tool, along with our built-in help as well. It also presents any recent projects, so if your teammate accidentally closed your LabVIEW and you don't know where you saved your project, they're pretty easy to find right there. And then the other part of the software orientation for the Getting Started window is that imaging tool, like I said, underneath Utilities for LabVIEW teams. This puts the new image on your Robo Rio every year, so it's very important. So let's take a brief look at the Robo Rio Robot Project window. This is the LabVIEW Project Explorer window, is what pops up here. And it sort of arranges all of the code and VIs that you have in your LabVIEW project. You can see here that any code you're going to need to edit over the course of developing your robot project is going to be located in the team code folder. The support code folder is all of our libraries and things like that that you shouldn't really be editing, but that need to be part of the project. Robot main is the name of the VI that communicates with the field control system, so talks to the FMS, and runs any team code that you've developed. This is your primary control loop for your robot project. Let's take a quick look at the driver station. This is super relevant to teams that program in any language, really, but also LabVIEW, because the driver station is actually written in LabVIEW, which I think is pretty neat. So you're using LabVIEW even if you think you're not. But looking at this first tab on the left-hand side is the Operations tab. This is where we can control what mode the robot is operating in. So you see we can choose from teleoperated or autonomous. Practice mode actually runs a full match. So if you want to see how that transition works from autonomous to teleop, that's a great way to test it. And then you have the all-important robot info section in the middle. All three of those lights need to be green in order to run your robot. If you're an experienced team, I'm sure you've had times when one of those lights wasn't green on the field. You know how frustrating that can be. So making sure all of that works in practice is really, really good. And then on the right-hand side, you can tab to messages mode. This is where any errors or things you've programmed for your Robo Rio to feed back to the driver station will show up. Going on to the next tab is what we call our Diagnostics tab. This shows what parts of the communication system are working or not working. So you can see we have 5 different radio lights underneath the communications header over there, and each one of those lights also needs to be lit up. You can also use this to reboot your Robo Rio or restart your robot code without walking over to your robot. And here we have an example of some error messages that might come back from your robot while you're running it.
So April, what do some of those error messages mean exactly? Like, what are some common ones that somebody might see?
A really common one, it will say that your, oh my goodness, it'll say that a server's not running and that you should check your firewalls. That's how you know that your Windows firewalls are interfering with the communication for the robot. So if you're seeing something like the MDNS server can't start, go check your firewalls. That's a really common one. Or if you're railing a loop, a lot of times it'll say that something is out of memory or a loop is running too fast. And that can be an indication that you have an untimed while loop somewhere. Cool. Moving down one more tab on the driver station, here's the Setup tab. This is where you go to type in your team number when you're trying to talk to your robot. You can also use this to configure match settings. So if, for example, something crazy happens and we have a minute of autonomous next year, you can go set that up for a minute of autonomous here. We've configured it with sort of default match settings, but you can change those at any time. And if you move down a tab on the right-hand side of the driver station, this is chart mode. This shows all the information we're getting back from the Robo Rio by default. So your battery voltage, what your packet loss percentage is, what percent of your CPU you're using. So if you're not getting communications, looking at chart tab can be really helpful in kind of figuring out why. And going down one more tab on the driver station, we have our USB devices. This is where you can see any controllers you have plugged into your computer, see all of those live joystick inputs to figure out what the A button actually is in your computer. And you can also combine messages in chart mode, though it can get really hard to read pretty quickly. And then the very last tab on our driver station is our Power and CAN tab. This is where you can go to see if your power light on your Robo Rio is red. Go to this tab after plugging it into your driver station, or after plugging it into your computer, and it'll tell you what rail on the Robo Rio is shorted, which is pretty neat. And then you can use the user manual to determine what voltage corresponds to which rail. So for example, if it says, hey, I have a fault on my 5-volt rail, we know that's probably the DIO on the Robo Rio.
So April, I got to ask, there's quite a few people in chat talking about there was something about a 60-second autonomous listed in there. Is that a leak for the 2018
That
game?
was a total random number I came up with.
Total random. So
total random number.
By the way, when it comes out to be 60 seconds this year, we're going to know how badly you lied to us.
If it comes out to be 60 seconds, I think some people at first would be very mad at me for ruining their surprise. I promise I'm not involved with that in any capacity. Cool. So moving on from the driver station, this should be something you guys are all pretty familiar with. This is your Robo Rio. Moving around, we've just sort of highlighted all of the inputs and outputs we have on this thing. You can typically we want to use that USB port for programming and deployment, and definitely for imaging. It's the most stable connection you can get back from the Robo Rio. You can use those the other USB ports to connect to that all-important webcam on your robot, and then the Ethernet port that should be connected to your radio anytime your robot is on the field. The Robo Rio actually has 4 zip tie mounting holes around the outside, so you don't need to drill into it. You can just zip tie it to whatever you want. And then we have our PWM ports, the accelerometer, our RSL port. We have that MXP custom electronics expansion port in the middle. So if you want to design your own boards or work with a third-party partner board, those go there. And then all of our I2C SPI, RS-232, and CAN interfaces.
So, April, before we move forward, why don't we start one of our trivia questions that we had for this evening that we had? And so we'll ask that. We'll let that run for a little bit, and we'll keep on the presentation, and then we'll pick a winner in just a few minutes. So what's the first one you got in mind today?
Sounds good. The first trivia question is, what is the name of the primary control VI for all LabVIEW robot projects?
So if you didn't get that, we'll have it up in chat here in just a moment. Actually, on the screen, it's actually up here. So if you know the answer to it, once again, make sure you are following the channel in order to enter and then type in the answer in the chat. So you'll see it running there. We'll let that run for just a few minutes, and we'll select a winner for it. We can give a clue, I think, for what as well. It is it's 2 words, right? 2 words.
Yes, this is a 2-word answer.
Yep, 2-word answer, guys. So put that in the chat. We'll be giving away for this prize is a T-shirt courtesy of Any Mark, a steampunk T-shirt from their site. And if you do want, make sure you send me your contact information or PM.
Cool. So moving on, talking about that MXP, the MyRIO expansion port, we do actually have a developer's guide for the MXP port. So if you're just really feeling it and you want to go design your own board, you're absolutely welcome to do that. Be sure to check the official rules from FIRST to be sure that any accessories you design or use are competition legal. And then looking at some of the other MXP accessories we have, we do provide some prototyping boards and breadboard type accessories. And then some of our third-party partners, you can get these at AndyMark, do make boards that fit in the MXP slot. So if you don't feel like designing your own board and you want to use something that is likely competition legal, go check them out. Let's look at setting up our Robo Rio. This is a pretty quick and easy 4-step process to get it ready to run LabVIEW code. The first thing you're going to want to do, like I said, is install that update suite to get the most up-to-date image. Connect your Robo Rio to a power supply. They are not USB powered, so they do need that external 12-volt supply. Connect your Robo Rio to your PC over USB, and then open and run that Robo Rio imaging tool. Make sure that you put the team number you want to use in there, because that does need to correspond with whatever team number you give the driver station, because that's how they talk to each other. Cool. So let's look at how do we go from opening LabVIEW to driving a robot in 5 quick and easy steps. So step 1 is you should be able to do this in simulation if you're following along, but if you're using real hardware, you need to properly set up the Robo Rio controller and all of your other electronics on your robot first. So step 1 is open LabVIEW. And then from that Getting Started window, you can either go to New and FRC Robo Rio Project, or just click on the FRC Robo Rio Project link there on the front page. This is going to open your default Robo Rio project. If we click to the next slide, this is where we can configure our Robo Rio robot project. You can give it a name here. I highly suggest calling it something other than 2017 Robot Project, because you'll end up with 2017 Robot Project version 10 pretty quickly. So if you want to keep them straight, I highly recommend naming it something different. And then again, give it the team number you want to use to drive it. We have a few different sort of sample projects here with Arcade Drive, a couple drives with an ARM, and then using Command and Control, which we'll get into in a later presentation.
So April, just to ask you, because something really important, I think in any sort of file structuring program is coming up with a really good way to save files and file numbering and file naming. Do you have any suggestions for doing something like that to make it really easy to keep track of what you're on?
Yeah, I highly recommend giving it a descriptive name. So if you know that you want to use this project to develop, say, you're going to put encoders on your robot in this project and that's what you're working on, call this Robot Encoders or 2017 Robot Encoders. And then as you save it, you can either add more details to it or put notes right in your VI. You can double click anywhere in any VI in LabVIEW and it'll make a note for you. So you can put a lot of notes in there and say, hey, this is what I'm doing in this VI. And that's a great way to provide information without cluttering up your file names.
All right, so we're going to do a quick drawing for the contest winner. Of course, the answer was Robot Main. I didn't know that, but that is the answer for it. And congratulations to Olazola5818. You have won the contest and the T-shirt. Make sure you PM me your contact information.
Yay, congratulations.
Yeah.
Fun. Cool. So once you've configured your Robo Rio robot project, you'll click Finish there. It'll stop being grayed out. And then it'll open up this project, that's Project Explorer window that we just looked at. And given the answer to the trivia question was Robot Main, that's the VI we actually want to go run. So we'll double click on Robot Main from this window. When you're actually looking at a VI, you can press Control E and it'll open up the front panel and the block diagram. And we'll talk more about that later. So once we've opened up Robot Main, we can go ahead and select our target, which is step 4 of this process. When you're looking at Robot Main, you'll see that little yellow text box in the lower left-hand corner of the screen. That's actually what target we're going to deploy this to. So by default, it's going to be looking for a Robo Rio to deploy to. We can actually click on that and change the target to actually point at your computer. When you point it back at your computer, it'll automatically open up our robot simulation window, and it'll go through a little bit of an opening process to open up all the supporting files, but you'll be able to test any drive code actually in simulation without needing an actual robot. So once you've toggled that over to a simulated Robo Rio, which I'm doing in my case because I don't have a robot at my desk, we can move on to step 5, which is to click that white run arrow at the top left-hand corner of Robot Main. This is actually what's going to send your code to the Robo Rio or your simulation, and at that point you should be able to drive your robot given that everything else is hooked up correctly. So let's look at some quick resources here. These are places you can go to get FRC specific help with LabVIEW. NI.com/FRC is our main platform for that. We have a really active chat board and a discussion forum. I'm on there all the time. A bunch of the engineers here at NI do follow that really closely. And then during build season, you can actually give us a call. I might pick up the phone. Some of my colleagues might pick up the phone. But we're happy to help you guys out if you have any questions. Cool. So let's move on to actually looking at LabVIEW. So we're going to briefly talk about what is LabVIEW, look at the development environment, go over some programming fundamentals, and then some things that can help you with troubleshooting your robot code. So what is LabVIEW? I keep saying this. LabVIEW is a graphical programming environment. It's not actually a programming language. The language it's written in is G, and LabVIEW is just a programming environment. So just like Eclipse or anything like that, that's what it is. But we use it to develop sophisticated measurement, test, and control systems. So we have this graphical drag and drop code style that's a lot easier for most engineers to pick up than traditional text-based languages. Really what we care about in FIRST is that supercritical teleop and autonomous code. So when we look at our teleop code, it sort of lives in 3 places. We're going to want to initialize in the begin VI. So this is where we set up our joysticks, our motors, anything we want to refer to later. We set up their references in begin. We then use those references in teleop to actually access those devices. And then we close those references out and finish to release them to be used by the next program. When you're modifying that FRC robot project template, do not modify robot main. You don't really need to, and putting stuff there can really slow down that main communication loop that we definitely want to keep as fast as possible. Looking at our autonomous code, it's going to be pretty similar to teleop in that it's going to use those same references we set up in begin. We can use in autonomous. We don't want to close them yet because we want to use them again in teleop. So we definitely want to make sure we're only closing our references in finish and only opening them in begin. So looking at our robot main.vi, because you definitely want to have an understanding of how this works. In our main Project Explorer, again, we have that Project Explorer window. It lists all your files. We have our front panel here, which is going to be the window with the gray grid on it by default. You can toggle the grid off if you don't like it. I like it because it helps me tell the 2 windows apart. But this is going to be kind of your user interface. This is where you're going to have any buttons, any inputs. Things like that are going to live on the front panel. And then the window with the white panel, with the white background, you can open this up by again, pressing that Control-E shortcut. We're going to view block diagram. This is where your actual code lives. So this is where you can see, oh, I have some loops here. I have some sub-VIs. I have some notes. This is where things are actually happening. You can kind of think of LabVIEW as an old analog radio. You have some buttons, some dials, some screens on the front panel, and then all your wiring is actually going to be on your block diagram. So looking at that LabVIEW Project Explorer window, we have a couple of sort of standard LabVIEW file extensions. Your project files are going to have a .lvproj extension. This is going to sort of own all of your VIs, but the neat thing is that a VI can be owned by multiple projects. So a VI is a virtual instrument. It's what we call that combination of a front panel and a block diagram. So it can be called by multiple projects at the same time, which is pretty cool. You can also make custom controls. So if you want a really specific dial or something like that, you can develop that and then use it, and it's going to have a .ctl extension. The other cool thing about the Project Explorer window is you can actually test your connection to a Robo Rio right from this window. You'll see where it says target, and it should say Robo Rio your team number FRC.local. So in this case, we're team 1234, because that's very original.
It's the very most creative team name ever.
Right. I'm running out of numbers. I used to use 9999, but we're getting up there in FRC teams, and that's going to be someone's team number soon. You can right-click on that target and select Connect to Target. If it connects successfully, it'll say Connection Established, and that little button next to the roboRIO will turn bright green. So it's a really quick and easy way to test that you have a connection before you start trying to deploy code. So looking at parts of a VI, looking at the front panel, like I said, the front panel is kind of your user interface. This is where your controls or your inputs, any buttons, knobs, sliders, text box entries, things like that are all going to live here, as well as your indicators or your outputs. That's going to be like a numeric display, graphs, those Boolean LEDs you see over there. They turn like bright green if they're true, dark green if they're false. When you're laying out your front panel, you kind of want to think about what data do I want to see from my robot and how do I know that it's working like I think it should. These are super useful in debugging and troubleshooting because you can get live real-time data back from your robot. So if you're testing a control algorithm, you're testing encoders, and you know what those values should be coming back as, you can print those to your front panel and see them real time, which is really cool. If you right-click anywhere in your front panel, it'll bring up what we call the controls palette. This is where you can sort of click through and pick and choose what controls or indicators you want to put on your front panel. It gives you all the choices that you want to put in. They're really, really extensive. So you can also use the search feature in the upper right-hand corner. If you know that, for example, you want a numeric entry box, you can just search numeric, and it'll give you those entry boxes really quick and easy.
Hey, April, I wanted to ask, we have a few questions that are coming up, but there's one that was specific to a slide you were just on. Rich4327 asked, what is the advantage of front panel for those in FRC? Like, what advantage can they get out of using that?
Front panels are great, like I said, for that live testing. I can be connected to my robot over Wi-Fi in my shop, driving it around, and I could be returning the image I'm getting from the camera. And if I'm doing any sort of vision analysis on that, I could see how many rectangles I'm creating, for example, or what values it thinks are coming back from the camera, if it's identifying something as light or dark. And I can see that all in real time, but I can also adjust that in real time. So I can set up some controls that correspond to what my light threshold, for example, if we're continuing with that vision example, what my light thresholds should be. And if I say, oh, okay, 5 is too low, let me bump it to 7. Oh, that's too high, let me bring it down to 6. I can do all of that really, really quick. So it really speeds up any sort of code iteration once you have the basic structure in place. Cool. Awesome. So let's move on to parts of VI, looking at a block diagram. Like I said before, the block diagram is the code for LabVIEW. That's where your actual code is going to live. In LabVIEW, those graphical blocks are connected with wires to control the execution. And really, those wires help enforce data flow, and we'll talk more on that in a little bit. We have sort of 3 main items that you can see here on our front panel. If something corresponds, or on our block diagram, sorry, if something corresponds to an object on the front panel, we call that a terminal. So you can see that we have a little terminal here called finish that corresponds to that finish button we saw on the front panel earlier. Any of these little squares you see are sub-VIs. So you can actually open those up. Those have a front panel and a block diagram of their own, and you can make layers that way. They're kind of like functions. And then you can see we have some loop structures here. You can see we have a while loop, and then a case structure as well, which works a lot like a select, or I'm forgetting what the other one is. It's later in my notes. And we'll talk more about how do I make choices in LabVIEW later.
So, April, I was going to say, why don't we start our second trivia question here while we have a quick break as we get into the next thing. What do we have for trivia question number 2 for our viewers?
So, trivia question number 2 is, where do we write all of our code in LabVIEW? Again, this is a 2-word answer.
Two-word answer. So once again, if you're interested and you think you know the answer, go ahead and type that into chat. Just popping up on the screen now, and make sure you click that follow button or sub. Make sure you're entered for that. So start typing that in. Spam as much as you want. We don't care, guys. Have some fun with it, and good luck. We'll be doing this drawing in just a few minutes.
Cool. So, and very similar to what we saw for the front panel, in the block, if you right-click anywhere in the block diagram, it's going to open up the functions palette. And this is where all of your VIs, functions, constants live. You can make an array, make a cluster, things like that. This is where you can go to get all of those things. The neat thing about the functions palette is that we have FRC specific palettes here. So our WPI robotics library lives here. Our FIRST vision library lives here. The PID library lives here. So this is where you can go to find all of those VIs and see what you have available to use, kind of what's in your toolbox. Thinking of the palettes as toolboxes is a really good way to sort of get your mind around them. It's where you keep all your tools and then you can just go pick the ones you need at the time. So again, looking at terminals, like I said, these correspond between front panel objects and block diagram objects. So you can see here that we have this numeric control called scalar on our front panel, and then we have a terminal on the block diagram also called scalar. If I were to go in and change the name of scalar to something else, both names would update at the same time. So that value gets directly put to the scalar terminal in the block diagram and then run. You can see it works the same way with indicators. When that motor value terminal gets the motor value terminal gets a value, it'll print back to that front panel in the output box. So let's talk about Dataflow Programming. I mentioned earlier that the order of execution in LabVIEW is controlled by how the wires are connected. Excuse me. So each function is going to execute when all of the inputs are present. So there's a lot of parallelism going on in LabVIEW. A lot of things can be happening at the same time, provided that all of their inputs are satisfied. So if we look at this example here, you can see that the multiplier by 2 on the very bottom of this window wouldn't execute until it got the value down from A. So a really good way to find out what order things are going to execute in is to click on this little light bulb and turn on what we call highlight execution. It will actually slow down all of your code so you can see things happen in real time. Those little dots kind of look like Pac-Man to me. Will run along the wires as things happen, and you can see what order your code executes in. It's a really, really good way to make sure that your code is executing in the order you think it is, you're transitioning between states in a state machine correctly, your logic is right, things like that. The one thing to keep in mind with highlight execution is it slows everything down. So if you're running robot code on your Robo Rio and you turn on highlight execution, you're immediately going to get an error that says, hey, your main control loop is running too slow and we can't maintain communication. So this is mostly used when you're developing code to, like I said, test logic, test execution, and order of operations, but you don't really want to use it on your robot.
One thing I just want to jump in and say, because somebody asked, and we forgot to mention, the trivia contest, which will be closing in just a minute here, you will be winning a pair of compliant wheels from Andy Marks. They'll be shipping you out a couple 4-inch compliant wheels.
Cool. Yeah, that's important. We got to know what we're winning.
Right? Yeah. And we, by the way, for those who asked, we haven't given away the Robo Rio yet. The National Instruments Robo Rio, that's coming in just a little bit. So be patient. It will come out soon enough, and then you'll get your chance to win that.
Cool. So the next thing we want to talk about here real quick is the LabVIEW Toolbar. And this is where any of your execution or overall type tools will live. You have your main run tools. This is your should be white run arrow. If your run arrow looks like this, it's what we call a broken run arrow. And that means you have an error somewhere in your code that's preventing LabVIEW from compiling and running. You can actually click on that arrow, and we'll look at this later, and it will bring up an error box and say, hey, this is where it's broken. We'll look at that more later. Again, you have your standard debugging tools, so highlight execution, your probe wires, we'll talk about that more later. And then if you actually want to step into your code, you can still set breakpoints and step into a loop and step by step through your code over functions, things like that. You can change the font of your LabVIEW. If you want to pull a really great prank on someone, set the default value of their font to Comic Sans. They will not like you very much.
Yeah, don't do that. Nobody uses Comic Sans.
It's really funny.
But do it for Germans.
And then you have your arranging tools. This can really help make your block diagram look really neat. You can highlight a few VIs or highlight some wires and make them all immediately line up or space themselves evenly or things like that. The very last button on your LabVIEW toolbar is what we call your cleanup button. You can press this and LabVIEW will immediately optimize your VI to make everything as close together and as small as possible. This is really useful for small sections of code that you've highlighted. I don't suggest clicking this on like robot main because it will quickly become unrecognizable and unreadable. But really, really useful if you've like wired a bunch of stuff and your wires are all, you have a lot of bends in them or things like that. It can clean them up really, really quick.
All right, April, let's find out who's going to win the compliant list. By the way, there are half-inch hex, by the way, for those who were asking. So congratulations. The winner of that is Robo Coder 1. Actually, we do have to re-roll. I apologize because Robo Coder 1 says it's not following. So we do have to re-roll for that. So you have to make sure you follow for that as well. So the winner for that is actually Stone Money 533. Stone Money 533. Congratulations. You won the AnyMark compliant wheels. So go ahead and shoot me a message.
And the answer to that trivia question was block diagram.
I kind of spoiled it. I brought it up on that
because
slide.
we
Yeah.
just talked about it. So if any of you missed it, shame. Cool. I believe we have one more trivia question left later in the show, right?
We got one more coming up, and then at some point we'll be doing the Robo Rio giveaway.
Cool. So moving on, we want to look at the wires or different data types in LabVIEW. You might have noticed over a couple of my examples that my wires have been different colors. That's because LabVIEW is really fun and colorful to look at, but those colors actually all mean something. So each data type has its own color wire. So you can see here that we have a floating point. So our floating point numbers, which are numbers that have decimals, are going to be orange. Our integers are going to be blue. Our booleans are going to be green. Those can only be true and false. So a string, any sort of text, is going to be pink. An array is going to be the same color as the data type of the array. So in this case, we have an array of floating points. So it's still orange, but you can see that that wire is actually thicker than the initial floating point wire. So that's how you know it's an array. If you make it a 3D array, that wire will get even thicker and so on and so forth. And then the last data type is called a cluster. A cluster is just a group of other data types. So in this case, we've put both a floating point, an integer, and a string into a cluster. It's going to be this bright pink wire with the little dots down the middle. If you connect two wires together that don't have the same data type, you're going to get what we call a broken wire, which is basically just a type mismatch. It'll look like the wire with the X on it on your screen now. You can see that the left-hand side of that wire is a floating point and the right-hand side is a cluster. You can't connect different wires of different data types together, and that's going to give you a broken run arrow, and LabVIEW will go, hey, this is broken, you need to fix it before we can compile your code. Looking at loops in LabVIEW, a programming loop just allows the same piece of code to run for multiple times. The exit conditions are different for each type of loop. So we have your basic loops, a while loop and a for loop. A while loop will run until a stop condition is met. If you want to be technical, technically LabVIEW has do while loops, not while loops, if you know what the difference is. So in this case, it's going to run until someone presses that stop button on the front panel. A for loop, on the other hand, runs a set number of times. So you can either wire an integer to the what we call the end terminal, and it will run that number of times. So in this case, we wired 1,000, so this for loop would execute 1,000 times. You can also actually use the iteration counter, which is that little I square in the lower left-hand corner, to specify to use the number of times it's run in some logic to only execute it so many times. So that will actually return how many times it's run. So you can say, hey, if this value is greater than 15, stop my loop. So that's a neat way to do some logic in there as well. So I talked briefly about sub-VIs earlier. Sub-VIs are going to appear as those little squares on your LabVIEW block diagram. These are basically functions, and they're just going to have more code inside of them. So in this case, and this is the example we'll be walking through here in a little bit, we decided that we wanted to scale our joysticks down when we get the input, because 0 to 1 was way too much on our wheels, for example, and we were browning out, so we want to scale it down by 2% or whatever. So we've actually made this compact little sub-VI. Sub-VIs help keep your code really neat and clean, and it can help it stay very readable, even if you have a lot of complicated logic going on. The neat thing about sub-VIs is they have a connector pane, so you can actually pick and choose where you want to be able to wire inputs and get outputs from your sub-VI. And we'll look more at that when we do our live example, which I think we'll jump into now, Tyler.
Alrighty, so we can jump into a live example here that you're going to be showing. What are you going to be showing in particular?
We are actually going to go ahead and make this joystick scalar sub-VI and show you how you make a sub-VI, and then how you just write some simple code in LabVIEW as well.
All right, we are good to go.
All right, awesome. So you guys should be able to see my LabVIEW project here. I just have a default robot project. Note mine is still called 2017 Robot Project. That's how you know it's not important. But we're looking at robot main. So over here we have our front panel. Over here we have our block diagram. Now I want to go and scale my joysticks, right? And so we're getting that information in our teleop sub-VI, which is right here on the screen. So in order to open up the sub-VI, I'm going to double click on it, and it's going to open up over here. You see that we have another front panel, and then I can either press Control E, which is the shortcut, or navigate to View. Should be under View. Shows you how often I use it. Maybe it's under Window. There you go. Window Show Block Diagram. I pretty much exclusively use the shortcut. And this is the block diagram that I have for teleop. So over here, you can see that we're getting our refnum for our joystick, we're getting the values, reading these off the array, and publishing this to the arcade drive, which then gets sent to our motors. So this value right here is coming directly off the joystick and going to our motor. This can be really problematic sometimes because if you ramp your motors up too quickly, you can cause brownouts by pulling too much amperage out of your battery. And this can actually cause your robot to lose connection and need to restart in the middle of a match, which is super inconvenient. So in order to avoid this, we're going to scale our joystick down a little. So I want to go make a new sub-VI. So I'm just going to go to File, New VI, and we'll make these windows big. Cool. So I have a blank front panel and a blank block diagram. I know that I want to have two inputs, right? I want to get the initial value from my joystick. So we'll go ahead and just make a numeric control for that. And we'll call this joystick value. And you can see that the name updated on the front panel and on the block diagram. And then I also want an input for how much I'm going to scale it by, right? So again, I'll right click on my front panel, click here, go to numeric control, and get another one, and we'll call this our scalar. So you can see we have two things here. Now if I want to be a good programmer and put notes in my code, I can just double click and say, hey, these are the inputs. So now if anyone else opens this up, they know that these are values we're expected to provide. So great. So now I just want to scale it, right? So all I want to do is multiply our joystick value by our scalar. So I can right click over here, navigate to numeric, and then select multiply. If I didn't know where that was, I can also right click, click on search, and then type in I want to multiply something. And it'll say, oh look, right here, multiply. And I can just double click on this, and it shows me where it is in the palette so that I can find it next time. So I'll click and drag and drop that over here. I don't need my functions palette anymore, so I'll close that out. In order to send these values to our multiplication, I'm just going to click on the wire terminal on my scalar, and then click on the input terminal over here. You'll see LabVIEW does some sort of automatic routing of your wires, so they're not just like squiggly and all over the place. But if I wanted to clean that up, I can click on this cleanup button, and you can see that it does an alright job. I don't really like it. So I'm gonna undo that and put it back to the way I had it. I'm just going to bring that in because you want your code to stay sort of small and readable. Typically, we program from left to right in LabVIEW, so you can sort of scroll across and read it. You can go top to bottom, you can go right to left. Probably safe to stick with left to right. And so now I want to get this value out of my multiplication. I can either make a indicator over here and wire it up, or I can actually just right-click on this wire terminal and go to Create Indicator. Boom, it's right there. And then I can go ahead and say this is the value we actually want to send to the joystick. So we'll call this final joystick value. You can see LabVIEW stuck it up here. I'm going to bring it down, put it by my other ones, and then
April,
call
is there a way
it.
we can zoom in just a little bit on this?
No, you cannot zoom in LabVIEW, actually. In LabVIEW NXG you can, but
okay.
FIRST isn't on NXG yet. So they're going to be small. Sorry about that, guys. So now we've set this up, right? And this is our sub-VI. We're going to want to connect our inputs to our connector pane so that we can actually access them back in our other block diagram in Teleop. So I'm just going to select the input and then click on the little tiny terminal block up here. And then click on that. You can see that this, hopefully you can see that this turns orange. And then I'll go ahead and wire this one a couple spots below it, wire that to my scaler, click over here and wire that to my joystick value. The other fun thing about making sub-VIs is you get to make custom icons. So I can click on this, it'll open up this icon editor. I can go ahead and clear this. And I can just make my own icons. So we'll make this blue. I like this color blue. And then we'll put some stuff on it. We probably want to give this a descriptive name so I know what it is. So oops, I don't want that to be blue. Make that black. Probably want to give this a descriptive name so I know what this sub-VI does. Otherwise, you'll end up with a lot of sub-VIs that look exactly the same and your code will be impossible to read and no one but you will know what's going on. And then we have a whole lot of these fun little glyphs. So I'm just going to search scale. What are some of these look interesting? This looks like kind of like what I want to do here. I'm taking a value and making it something else. So when I'm happy with my icon, I can click OK. And then I definitely want to save my sub-VI before I lose it. So I'll go to File, Save As. It's just going to put this in this temporary folder here that I've created. And we'll call this Scale Joystick Value. Great, so now we've got this. And now we want to go back to our Teleop VI. We'll make that big. So now we can see our Teleop VI, and I want to put that other VI on here now, right? So if we go to our project window, you'll see that it automatically added my VI here because I made that new VI while I had this project open. Otherwise, you could right-click and browse, and you can add VIs, files, things like that. So if I want to get to this VI, I can either click and drag here, and it'll pop over. I can also now search for, oops, what did I call that? Scale joystick value. Can't type it right. But you can also search for it and find it that way. I usually grab them from the Project Explorer because then I know I'm getting the VI I want. So I'll put that over here. I'm going to go ahead and delete this wire. So you can see I have these broken wires here. This is just because that end's not connected to anything. You can clean up broken wires with Control B. So once those are cleaned up, I'll drop that in here. So this is going to go, you can see if I hover over these terminals, it tells me what I'm connecting it to. So I know, say, hey, that's my joystick value. And then I can actually clean up code a little. Right click here and go create constant. And we'll give this a multiplier of 0.8. So we turn it down just a little bit, but we're not taking away all of the power. And then we'll wire that final joystick value back to our x-axis. And now we're done. We've scaled our joysticks, we can save our project, and we're good to go. And that's the end of our live demo.
All right, we'll jump back into the other one. I think it's probably a good time to start our third trivia question. What do you think, April?
Sure, I think now is a great time.
All right, go ahead. What is it?
All right, our third trivia question is, what element in LabVIEW do we use to show data from a VI?
So just a reminder, once again, you do have to follow or sub in order to be in. So go ahead and start typing that answer into the chat, and we'll have Nightbot roll for that in just a little bit as well. So we'll give that a few minutes and then roll for that. So good luck, everybody.
And this is a one-word answer. I had to change it up a little. This is just one word.
Everybody's guessing front panel.
Now, we're not talking about where we show the data. What element actually displays data that we're getting back from any logic or math that we did in the block diagram?
Oh, see, I think we got a couple who have answered it correctly. So, all right, we'll let that run for a little bit and see who gets it right.
We have to make it a little bit harder as we go on. You got to pay attention.
Or if you're in chat, you just read it what everybody else typed and start typing down. Right? So.
It's true. Power of the mob, right?
All right, good luck, everybody.
Cool. So we'll go on. We just have a couple more slides here, and then we'll get things wrapped up. So now that we've gone through that programming demonstration, we want to look at how do I make decisions in LabVIEW. If I have two inputs and I want to pick one, how do I do that? We have a couple of different ways. One is by using a case structure. This is pretty much the equivalent to like an if-else statement or a switch statement, that's the word I couldn't think of earlier, in any standard text-based language. So the case structure is going to have one or more sub-diagrams. So you can see here in sort of option A, we've wired this Boolean control, and we have a sub-diagram for true and a sub-diagram for false. If this Boolean comes in as a true, anything that's in the true case is going to execute, and what's in the false case will not execute. Looking at options B and C, you can also wire in enumerated lists or a numeric control. And again, anything that corresponds to what you've wired in as the case selector is the code that will run. So in this case, we have our enumerator says January, and whatever in this January case will run, but not what's in the February case.
And April, I just want to jump in. I apologize because I forgot again. What's given away for this trivia contest is we're giving away another steampunk shirt courtesy of AndyMark. So the steampunk shirt on AndyMark's website, that's what we're giving away.
They're pretty cool. I have one.
Yeah, so. And once again, as everybody asked, no, we didn't give away the Robo Rio yet. That will be coming after this. So stick around, get in the chat for that.
Yep, you definitely want to be in the chat for that one. So. Cool. And then the other option for making decisions in LabVIEW is what we call a select block. This is a super quick and easy way to make a decision on a true-false Boolean. You can wire one option into the true, one option into the false, your selector down the middle, and then it will return whichever value has been chosen. The important thing to keep in mind about selects is that they do have to be the same data type in the true and the false, because it does get wired out of one wire. Cool. So I wanted to take a quick second to look at sort of the complicated data type in LabVIEW. That's clusters. Clusters is just a data structure that groups other data types together. Your elements either have to be all controls or indicators. And a really great way to think about it is sort of different wires bundled into a cable. It's a lot easier on your robot to sort of wrap all your wires together and then pass one bundle all the way around your frame over to the other part of your robot, rather than trying to individually run each wire. Clusters kind of do that in LabVIEW. I want to take a second to look at the different cluster functions we have. You can use bundle and unbundle to get things into and out of a cluster. So looking here, we have three controls here: a numeric, a string, and a Boolean. We've used our cluster bundle to put these all together, and they're going to get bundled in the order we wired them in. So it's going to go numeric, string, Boolean. And then we have a couple ways to get them out of that cluster. So you can use an unbundle, which is the one that looks just like the bundle, or the unbundle by name, which is really, really helpful because it actually tells you what you're unbundling. You can click on any of those names and select anything else in the cluster. So for example, if I just want the numeric, I can only make that one item tall and then only unbundle the numeric. That's what we're using on the bottom is the bundle by name. And you can see here that we're only sort of redetermining two values here. We've reassigned the numeric to 1 and the Boolean to true, but the string will stay the same as whatever the string value was on that input cluster. So it's really useful if you're passing data around loops through a shift register. You can put it into a cluster and then only change the relevant data in each case. Speaking of shift registers, they are a great way to access previous loop data. You can set them up on the left or right border of loop structures by right-clicking on a terminal, which are those little squares on the loop edges, and selecting Add Shift Register. The right terminal is going to store the data on completion of the iteration. Tyler, I think if you click, we have an animation here.
I did not have one.
All right, don't worry about it.
All right.
And it sort of runs around the while loop back to the left terminal, and then that's the data that's provided at the start of the next iteration. This is a really great way to do adaptive control or pass values that you need sort of around and around your loops. So the last thing I want to talk about is how do you get help in LabVIEW? Say you're programming along and you run across a function you haven't used before, or you don't know what inputs a sub-VI is looking for. Context help will be your best friend. You can press Control-H to open it, and it opens a little tiny window on your screen. And then whatever you're moused over, the short help will display for it. So here you can see this is like we were moused over the read from spreadsheet file VI. It's telling us what that VI is expecting and what that VI will return. If you read through the short help and you're like, hey, I really need more help on this, you can click on detailed help and it will automatically pull up the entire help article for that sub-VI. All of our first sub-VIs are well documented. They all have help, they all have examples. So this is a great way to find out what your VI is expecting and potentially figure out why it's not doing what you think it should.
Hey, April, I want to ask, because I was accidentally on the wrong slide there for a second in regards to that loop animation. So will this slide deck, is this available for somebody to download later on too that they can go through?
We will have it posted on ni.com/FRC. You can download it and go through it. There are notes on the slides if you want those. You can also download it and use it to give presentations at other teams, do your own webinars, things like that. Totally free for you guys to use. So we'll have that on ni.com/FRC tomorrow.
Awesome. Let's also do that last giveaway as well too. So April, what was the correct answer for the question, what element of LabVIEW do we use to show data from a VI?
That is the indicator, Tyler. So that's what's going to actually display the data back on our front panel are going to be those indicators.
All right, and once again, guys, you do have to follow, so I will re-roll if you're not following. So the winner of it is going to be Bonk Johnson TTV. Congratulations, Bonk Johnson TTV. So once again, if you're not following, I can't give you the prize. That's just the rules for it, guys. Make sure you're doing that. So Bonk Johnson TTV, shoot me a message, and you'll get an Andy Mark t-shirt. Congratulations.
Awesome. So we talked about context help. Super, super useful. I use it all the time when I'm programming. If you do need a little bit more help, you can actually look at the LabVIEW help as well. This is going to contain super detailed descriptions and instructions for pretty much all of our palettes, the menus, the tools, VIs, functions, things like that. You can get to the help by either going on your main toolbar, going Help, LabVIEW Help, clicking on that detailed help link in a context help window, or right-clicking on any object on your front panel or your block diagram and selecting Help, or by pressing F1. So we have a ton of ways to get to the help if you need it. Use whatever's most convenient for you. It's a really, really great resource. All of this is also online, so you can just Google help me with this VI, and it'll direct you to those help pages as well. If you've gone through the help and you're still not quite getting it, a great way to sort of figure out what VIs are looking for is by looking at some examples. You can find our FRC specific examples either by going to the Support tab on your Getting Started window and clicking on Find FRC Examples, or Help, Find Examples, and browse to the FRC Robotics folder. If you go through the Find Examples window, you will also see any other examples you have for any toolkits or other things you might have installed on your computer. So all of our basic LabVIEW examples are there. All of our RT LabVIEW examples are there. Things like that. Our example finder is also searchable. So you can search encoders and it'll immediately bring up our encoders example. Our examples are really, really good for testing subsystems because we already have them built out. You just need to give the correct reference, and it's a great way to test motors or encoders or sensors, things like that. It's really, really robust. So looking at debugging LabVIEW code, how do we fix a broken VI? You've programmed something, your VI is broken now. Your run arrow is not white, it looks like this, it's gray and it's sad. You can click on that and it'll bring up this error list. And in this error list, it will show you any VIs that have errors and what those errors are. So in this case, in this untitled 2 VI, I connected 2 terminals of different types. I connected a numeric control to a string indicator. Not cool, your wire is going to be broken. I can double click on that gray line where it says you've connected 2 terminals of different types, and it will actually take me to where I have committed the infraction. So no more searching for one missing semicolon somewhere. It'll actually take you right to the issue and you can get to fixing it and continue programming. And then the last thing I want to talk about is debugging with probes. Probes are really, really good for observing any intermediate data. So if you're getting data back from your joystick, you can either print that to the front panel, or you can set up a probe and use this to sort of monitor that data in the probe watch window. The other neat thing about probes is we have this little button that's the retain value or retain wire values button. It's not the yellow one, it's the gray one on the bottom there. And that actually toggles all of your wires to preserve their last value so you can probe them after you've run your code. Really, really useful in debugging. Make sure you turn it off before you build your executable and deploy it to your Robo Rio because it does take up a lot more memory. We have a lot of hotkeys in LabVIEW. You've heard me reference them a couple of times. This quick reference guide is on NI.com/FRC. You can also Google it and get that image. I had it set as my background for my computer for a really long time when I was learning LabVIEW because it makes things a lot faster, a lot easier. Highly recommend you print it out, put it somewhere by your programming area. It makes things go a lot quicker.
Also, for the giveaway, we're just going to have everybody memorize this. And if you're the first one to memorize it, that's how you get the Robo Rio, right?
Yeah, you have to answer every single hotkey. No, I don't have these all memorized, but it's really helpful. Cool, and then like I mentioned earlier, we have a ton of resources. We have video training on how do you learn LabVIEW just in general. All of our FRC specific stuff is going to be hosted on ni.com/FRC, but a lot of our general LabVIEW resources are helpful as well. Again, feel free to give us a call, 866-511-6285 during build season. If you have any hardware problems with your Robo Rios, we take calls in the off season for those as well. But we're happy to help you figure out logic, debug your code, figure out why things aren't working. FIRST is a passion project for a lot of us here at NI. I love it. A lot of us do. So we're happy to help you guys out. That's the end of the slides. You guys made it. You did it.
All right, April, hey, before we're going to do the drawing in just a moment here, but while I set up for that, I was wondering if you could just take a couple of the, why don't we do the first 2 questions that are on the Q&A at the bottom of our doc?
Sure.
I can read them off if you'd like.
Sure, I got them.
All right.
So the first question is, can NI and FRC create refs that start at start and show simple go, turn, stop, and then on through more complex? If you want to elaborate a bit more on that question, that'd be great. Happy to answer it. Just don't quite know what you're asking there.
All right.
On that first question, state machines can go in periodic tasks. They can go in teleop. You can make a sub-VI for them as well. Sort of whatever works best for your code there. Kind of up to you. Depends on where you're calling them. If you're calling them from Auton, you probably want them to go in your independent autonomous VI and not in your teleop VI. If you have issues with the beta, put them on the TeamForge. Go through there. Best way to do that. We do have more beta updates coming out across all 3 languages and the driver station, so stay tuned for those.
All right, let's have you answer one more, and then we're going to start the Robo Rio giveaway, everybody.
Sure. So deploying versus run as startup. Great question. So once you've built your Robo Rio project into an executable and you right-click on that, you'll have an option to deploy or run as startup. The difference there is deploy will put the code on the Robo Rio and run it, but whenever you power that Robo Rio off, that code gets wiped. It puts it in volatile memory. When you click run as startup, it actually saves your executable to the Robo Rio, so that when you power it off, power it back on, that code will immediately come up and start running again. So I highly recommend recommend using run as startup as often as possible. If you're doing really quick testing, deploy works just fine. Just remember that if you put the robot on the field after deploying the code and you've turned it off, your code will not be there when you turn it back on. So run as startup is the safe choice.
All right.
Do we want to do that giveaway?
I think we should. I don't know what everybody in chat thinks, but I think we're ready to do a pretty sweet giveaway for the Robo Rio. So there's going to be a couple things we got to go through first, folks. Very, very important. Make sure you are either followed or subbed to the channel. That will be your chance to get the Robo Rio. It's coming up in just a moment here. What we're going to do is we'll put it in the chat and also on the screen of what you have to type in. So there's going to be a keyword you have to type in order to win. So we're going to get that. I'm stalling a little bit because for some reason some of the text is not working. There we go. That's the way we do it sometimes here. I will ask you, April, one thing before we do this. So you were on an FRC team, before you came on the National Instruments. So can you kind of talk about that process? If somebody wants to, maybe work for National Instruments later on. What's kind of the process you went through, and how did you get involved with National Instruments?
Sure. So I actually am not an FRC alumni. I was never on a team in high school. It's just something I've been super passionate about. And I'm lucky to work on here at NI. If you're interested in working for NI, especially if you're a senior going into college, we have a ton of internships available. We love hiring FIRST kids because we know that you guys are awesome and you work hard, and that's what we look for here at NI. So going to ni.com and searching internship is a great way to get information on that. Otherwise, career fairs at your university when you get there is another great way to get involved. We recruit pretty heavily for college kids. I work pretty much exclusively in a department of college or recent grads, right? It's a lot of fun. I love working here. It's a great place. So highly recommend you check it out, especially as you go on through university. Please come intern here. Austin is a great city. Once you move here, you won't want to leave.
Yeah, I've not been to Austin yet, but I really want to stop by.
You gotta come visit.
Yeah, and if
it's amazing.
So can you visit the National Instruments headquarters? Is that possible?
Sure. Yeah, if you guys are interested in visiting us, feel free to reach out and we'll see what we can do. We have hosted teams on site. We've done tours, we've done workshops, things like that. Again, like I said, a lot of us are super passionate here about FIRST. It's obviously something NI is heavily invested in, but personally we're invested in it. So whatever we can do to help you guys be successful is what we want to do here.
Awesome. So with that said, I think we're ready to start the giveaway for the Robo Rio. Then afterwards, we're going to follow up. We'll answer the rest of the questions that are in there as well. So April, real quick, if you haven't seen, you have to either follow or subscribe. It's up to you. You can subscribe for free through Twitch Prime if you have Amazon Prime, or if your parents do as well too. Always be a follow, though, so you get you a ticket into this as well. But with that said, what does everybody in chat have to type in order to get a chance to win the Robo Rio?
So since you guys were so excited about this answer earlier, the keyword to type in is front panel. Is that one word or two, Tyler?
One word. Front panel, one word.
One word. No spaces. Front panel. That's what you have to type in.
I'm just curious who types it first. That's the real question. So, who typed it first? You don't get a better chance. But Bong Johnson, the first one, you already won something. No, you're still eligible to win, actually, too. So that's the great part. So we're just going to go ahead and spam front panel as many times as you want, guys. You only get, your main entry for it. But, if you spam it, that's always fun, too. So, all right, we did have a few more questions, April. Why don't we take those at this time?
Sure. So just moving down the list of questions I have here, for teams that use a mix of operating systems, can we use LabVIEW on Mac or Linux machines as well? Yes, we have LabVIEW support for Mac and Linux. I believe the installer you get shipped is for Windows. But if this is like a super critical thing to you, definitely reach out to us. We'll see what we can do. LabVIEW does work across all three operating systems. I can guarantee that. Cannot guarantee the driver station works on anything but Windows. So please don't show up at the field with anything other than a Windows machine, unless you want your FTAs to cry.
And cry they will, by the way.
Cry they will, yes. I'm actually really excited. I got chosen to be an FTA next year, so I'm really stoked about that. Please don't make me cry. So
for the 2018 season, you'll be an FTA?
Yes.
Do you know what events you're doing yet?
Not yet. I go to Manchester in January when it's very cold and snowy, and then hopefully I find out after that.
Oh, it's cold and snowy. Boo-hoo.
But if you're at any of the Texas events, find me. I'll be there.
Very cool. Yeah, make sure you say hi to April as well too, and ask her all the NI questions you want.
Go for it.
They seriously love it, right? I mean, it's
really
so
do.
cool to be able to talk about that stuff.
So the next two questions kind of go together. What sort of version control does NI recommend, and does LabVIEW play well with Git? The answer is yes. The team I mentor uses GitHub to do all of their source code control. You can also use SVT, any of the sort of industry standard source code control programs. LabVIEW does play well with them. Again, just save your files like you would any other program. GitHub is a great way to have a lot of people working on a project at once, because you can actually have two different sub-VIs be checked out by two different people, and they can be doing independent development, and then they can both check them back in, and one person can download and deploy robot main again. So that's pretty cool. The next question is, what's recommended for color vision problems? That's a good question. A lot of that comes down to camera settings, what USB camera you're using, things like that. We do have what we call our Vision Assistant, which is sort of an automated program that will go through and develop a vision algorithm for you. So you actually don't have to know how to write vision code. LabVIEW will develop it for you, and we have some extensive documentation on that on ni.com/FRC as well. If you have questions about NI products that are not FRC related, please reach out at support@ni.com.
That's so. What is the typical turnaround if somebody reaches out for support?
So you probably, if you have FRC specific questions, the forums on ni.com/FRC is the best way to get in touch with us. If only because we'll look at those on the weekends and our off time when we're not at our work email. Otherwise, first@ni.com is the FRC specific support email, and we typically have a 24-hour turnaround time on that.
Very cool. We did just have another question added in.
Yeah. So the next question I got was, any suggestions for handling multiple USB cameras feeding to the dashboard with LabVIEW? We had extensive problems getting both camera feeds on the field. Yeah, camera problems are fun. Yeah, so we had a lot of problems last year. We've actually done a lot of work on our camera server in the off season this year. We're rolling that out next year. I've actually gotten 8 cameras streaming at once. I don't recommend doing 8 cameras. Please do 2 or 4. But so it's a lot more robust this year. But all the sort of typical suggestions apply. Make your streams as small as you can. You don't need 30 frames a second. I guarantee it. You don't need 1080p streams for your robot cameras. So 120 by 240, 240 by 360, 15 frames a second, 10 frames a second will make that data a lot more manageable.
So we're going to take the question we have there, and I just got one more, and that's going to wrap up for questions. If you have more, just feel free to reach out to NI support and be willing to help you out with that.
Okay, so the next question is, where can we get more information on LabVIEW with version control? Sure, ni.com/FRC. I believe we have an article up there. If it's not posted yet, it should be in the next couple weeks. We spend the fall updating our documentation for the next year, and I know that's something a lot of teams have been asking for, so that's something we prioritize this year. And then the next question is, how do I make a robot with parameters that I can easily update, such as an XML, JSON, or text file with PID values and mappings? So this gets a little bit more complicated. It depends how you want to do it. You can tell LabVIEW to go find an external file. It's called File.io. Give it a Google, look at those sub-VIs. That's all going to be in our standard LabVIEW documentation, but you can point that to pretty much any type of file you want. XML, Excel, text file, those types of things. Give it what it needs to search for, and it can go dynamically pull those values for you. You could also make a case structure and then have different versions of those values in each case and send a selector to that case and say, hey, I want to run robot A or robot B or something like that.
All right, and that was the last question, I believe, right?
That's the last one I have.
All right. So before we wrap up, one last thing I want to mention, then we'll do the drawing here real quick, is that this is the first of 4 sessions we're going to be doing. So each one, we're going to be giving away a Robo Rio. So if you didn't get it this time, there's still more opportunities to get it as well. So make sure you keep that in mind. So we're going to be diving a bit more advanced into LabVIEW the next 3 episodes we do for this. You got them prepped already. So
I have so many Robo Rios.
so many to give away, apparently. So
yeah.
So over the next 3 episodes, maybe even the next one specifically, like what can we start to expect as we dive a bit more advanced into LabVIEW?
Sure. So the next one we're going to be doing is, this was sort of intro to LabVIEW. We're going to be looking at what we call advanced LabVIEW for FRC. So we're going to be looking at vision control. I think we have PID in there. How do I make my LabVIEW code more effective without making it terribly complicated? So how do I effectively use those decision-making tools we talked about earlier? Things like that is sort of what we cover in the next one. It's how do I take the next step in being an effective LabVIEW programmer? The one following, we're going to talk about command and control, which is our subsystem-based architecture. It's going to be a totally different project, totally different architecture. It's really, really cool. It's a lot sleeker. So if you're looking at, I don't know, something more modern, or you're used to working with those kinds of architectures, it's a really neat thing to look at. And then the last one is going to be targeted a little bit more towards mentors, and it's going to be how do we look at teaching LabVIEW effectively, how do we build good programmers, things like that.
Cool. So, and one thing I'll mention as well is that as we go through for this is our first one doing this, so we'd be delighted to have your feedback as well too. Anything
Absolutely.
that we can improve to make more engaging for you as well. So go ahead and hit up feedback at firstupdatesnow.com. We'd be delighted to have your feedback to keep everybody going in, and make sure you tell everybody about this too. There's a lot of teams that could really benefit from this, and I know we want to keep it a secret so we can win the Robo Rio, but seriously. Let as many teams know about this as possible, because this is really good stuff from the know. So, April, thank you so much for that. Let's do the drawing right now, and then we're going to wrap up the show. So, with that said, we want to give a huge congratulations to CL Carlson 1960. Congratulations, you've won it. The Robo Rio is coming to you. So shoot me a PM immediately in Twitch, or you can hit me up on Facebook or Discord with your mailing information. Huge congratulations to you, and thank you to everybody, by the way, for following the channel, subscribing. We know it's a requirement for that. It helps out Nightbot in order to do the drawing, so thank you very much for that. And we hope that you'll join us for this show and other shows that we have coming up very soon. Huge season coming up here on First Updates Now, and we're very excited for that as well. April, last things for LabVIEW that you wanted to discuss before we head off tonight?
No, I think we're good. I hope you guys got something out of this. Again, any feedback is appreciated. You can get that to Tyler. He'll get that to me. I do appreciate everyone tuning in and paying attention and following along. I'm really excited to see where this goes. So.
Yeah, and thanks for asking so many questions, chat. We really appreciate it. A engaged chat room and keeping everybody going. That's awesome. So thank you so much to everybody. Also, a big thank you to National Instruments for donating the Robo Rio. We're excited to see 3 more of those. Thank you to Annie Mark for donating for the trivia questions as well too. And don't forget, I do want to give a little plug for Annie Mark. Tomorrow at noon Eastern, they're going to be doing a new product giveaway on their website, anniemark.com. So make sure you go and check that out as well. So on behalf of April, I'm Tyler Olds, and I'd like to thank you for tuning in, and thank you to all of our mods keeping chat going. Thank you, everybody. We'll see you next time on First Updates Now. Tune in for a LabVIEW one in just a couple weeks as well. Win yourself a Robo Rio. We'll talk to you then.